Hey guys, it's Tuesday, March 26th, and you're watching Super Space Things. This time around, there's not going to be any me on the moon type atmosphere. I'm kind of redoing a couple of things, so there's no green screen this time around. But that's okay, because I'm just going to go ahead and knock through these couple of news items and get it over with. First off, the Dragon 2 capsule is on its way back, if it hasn't already splashed by the time this is released. The Dragon 2 capsule will be landing with experiments conducted on the ISS, as well as when it went up, it supplied the ISS with more experiment equipment so that they can conduct more tests. Along with that, NASA is actually sending up 3 new crew members to the ISS, and they look like the most metal astronauts I've ever seen. In big news, Planck has come back with results. The Planck 2 satellite was sent out to Lagrange point 2 to study the cosmic microwave background. The cosmic microwave background is kind of like the light emitted at the Big Bang. If you remember in one of my earlier episodes, I explained that light as it passes over a long distance in space, as well as passing deep gravitational wells, will stretch out and become a lower frequency. Well, the light emitted from the Big Bang has been traveling for a very, very, very long time, and it's gone down to microwaves. Now, the satellite is out right now trying to decipher it, and it actually completed its data and has been fully compiled, and the results are pretty interesting. One of the things that they are having a hard time with is the models that they have don't exactly match the way the universe is shaping up. There's a lot less signal than what they're expecting in certain areas of their map. You can see on this picture that these are the little blue areas are the areas where they're not getting much signal, and then the red and yellow areas are where they have signal. One of the other things that they found out was there's a lot less dark energy than they thought there was. However, they have discovered that there is more matter than they initially thought. This includes dark matter and regular matter. And dark matter, definition. Dark matter is matter that doesn't interact with the electromagnetic spectrum, so we can't really sense it or see it. The only real way we know it exists is because we can tell its gravitational pull in certain areas where there appears to be nothing. Another thing that's actually very interesting is there's this part of the Big Bang that says the universe had to expand much more quickly than the speed of light to get where it is now. And with these results, it appears that it didn't expand as quickly as they thought, but it still was fast. Now they're still grinding through everything to see what exactly the problem is, but so far that's from the 2 news reports I've heard and the article I've read, that's what the case seems to be. I'll let you know more about it as I find out more about it. In Curiosity news, Curiosity got another blue screen of death. This is happening a lot. This is like the 2nd or 3rd time it's happened. The reasoning is because of cosmic rays. Cosmic rays are basically one atom shot out from either an exploded star or shot out from our sun. Now one atom smashes into the electronics and switches a negative to a positive inside the circuitry, and that sends a huge error throughout the system, so they have to reboot and switch sides and reboot, and it's frustrating, but that's just part of having an object or having a rover in space on a planet with very little atmosphere. We don't deal with that as much because our atmosphere blocks out a lot of the radiation coming towards us, but if you do any astrophotography and you do long time exposures to do it, then you'll see that some of your pixels get blown out because of cosmic rays. Also, if you're near cement also radiates in a way that'll mess up your pictures. Now, also in Curiosity news, should I say HipsterBot, Mars is going to be going behind the sun for a little bit, so we won't be able to stay in contact with it for a little while. This will give the NASA scientists who are working on the Curiosity data to finish up some paperwork and come out with some finally published work from all that they've been doing. Also, James Webb Space Telescope finally has its wings almost complete. Now, the James Webb Space Telescope is another satellite going out to Lagrange Point 2. Lagrange Point 2 is an orbital point that we send satellites to so they can get further away from Earth and stay in really dark skies. The reason why is because we have a lot of our own radio and light pollution besides actual light, but also different satellites being around and being so close to the sun and the moon. We want to get things as far away as possible so we have as little influence on them as possible. So James Webb Space Telescope is like a very steroided out version of the Hubble. I think it's over 10 times as big, and it's going to be sensing in the infrared, which will let it see out further. I've been to a presentation by one of the scientists who worked on it out here, and he says that the James Webb Space Telescope will be able to see as far as the beginning of the universe will let us. He says there's going to be some sort of curtain where you just can't see past anymore, because that's when the universe began. This will let us see what the original forming galaxies in the universe, how they assembled, what they look like, their size, and so much more. Now, this thing finally, it's taken a long time for it to be built. They're gunning for it to launch in 2020, and it's finally got its wings done. The wings are basically, the scope is so huge that it just can't go up as is. A lot of satellites are just like that. They unfold in space. And this one's so massive that the wings that are complete actually have the rest of the primary mirror. So if you can imagine, it's got a primary mirror here in the middle, and then it's got more primary mirrors, the rest of the primary mirrors here on the side, and then they'll actually fling out to completely finish the disc shape of the primary mirror. The primary mirror is the mirror that light hits first in both telescopes and in satellites. I think that's going to be it for Super Space News this week. Thanks for joining us. Thanks for joining me. Sorry for the lack of awesome background and stuff. So you guys have a good week, and I will see you next week with more Super Space things. This is Ad the Human. I'll see you guys later.